Hey guys, welcome back to Rocket Gyan, my fellow space tubers. Here we are with another very cool mission to see and have, which is the JAXA's Hayabusa 2 mission, which is an asteroid sample return mission, and I'm really very excited about this. And yeah, because I have so much to talk about it. That's why I was a little late, so pardon me for that. But now here we are, and let's begin talking about this mission. I'm really very excited about this mission. I just can't tell you guys. Really very excited. Is it my voice low? Okay, I'll turn on. It should be good now. Okay, so here we are. As you can see right now, the Hayabusa 2 is a sample return capsule, I should say, not Hayabusa 2 itself, is around 26,000 kilometers away from the Earth. Okay, but before getting on to what is in store for us, let's have a look at what is a Hayabusa spacecraft, what is its mission, and everything. Okay, now we can have a look at the Hayabusa spacecraft, as in what is this mission and what is everything. So Hayabusa 2 mission is basically an asteroid sample return mission, which is operated by JAXA, and it is a follow-up mission of Hayabusa 1 mission, which actually returned asteroid samples back in 2010, June 2010. Thanks Marco for subscribing. So yeah, it's that. And here we are. And Hayabusa 2 was launched on December 3, 2014, and it arrived and rendezvoused to the near the Earth asteroid known as Ryugu asteroid on June 2018. So it remained there for 1.5 years, studying it, surveying it, and taking the samples, and now it is coming back to the Earth. Okay, so why, if you ask me, why Ryugu? Ryugu is basically an asteroid which is a carbonaceous asteroid. Okay, so what is a carbonaceous asteroid? Carbonaceous asteroids are expected to preserve the most pristine materials in the solar system, a mixture of minerals, ice, and organic compounds that interact with each other. Studying it is expected to provide additional knowledge on the origin and evolution of the inner planets. Basically, this asteroid is 3.6 around so much billion years old, and it was formed when the solar system was forming. So it has the, you can say, answers to the beginning of the solar system. That's why we are going there. Okay, that's the thing. um, I will answer every question, guys, just a bit now. I should be having, now we can have a look at what is in store for Hayabusa spacecraft. This is the Hayabusa spacecraft we have, as you can see here. If you can just tell me. Yeah, so this is an Hayabusa spacecraft. It is having DCAM 3, a deployable camera. I will tell you each and everything about this thing, but just have a look at the figure itself right now, and just try to visualize it. I will tell you everything. Okay, so don't worry. We have a DCAM 3, which is a deployable camera. Here we have that here. Then we have the star trackers. Star trackers are basically, actually the name itself suggests that only it tracks the star to for the navigation to take place, because in space we have nothing. We don't have any road signs, we don't have any directions to where to go. So for navigating in space, any spacecraft which goes to space has star trackers in it, which is basically, it tracks the stars which are away and remains at a constant distance with respect to the spacecraft whenever it is traveling. So it is like very far away. That's why you can assume that it is remaining at the constant distance. So that's the star trackers. Then we have the scientific instrument, near infrared red spectrometer here, for measuring the composition of the asteroid. Then we have the re-entry capsule. re-entry capsule is here. This is the here, which is basically now today returning back towards the earth. And yeah, it will enter at a speed of 12 kilometers per second. That's a very very fiery re-entry which we will be seeing. Then we will be having this Minerva to one small solar powered surface rover. This is a rover basically. In these two, we have two rovers here, and we have one rover here, Minerva 2-1 and Minerva 2-2. There are two rovers, three rovers and one lander. This mission has three rovers and one lander. So that is the thing. The small solar powered surface rover here, Minerva 2-2, Minerva 2-1. Then we have the LiDAR, which is laser altimeter, which is basically nothing but you can say measures the distance between the surface and the spacecraft. That is what it is used for. Then we have the sample horn, where which the sample will be collected. They have a three-chambered sample capsule. And what is the sampling process and how did it take place, I will tell you that also. Then we have this softballs target markers here. As you can see here, these are the target markers. These are launched from the spacecraft to basically have some markers on the asteroid to navigate the spacecraft to basically have a touchdown. That's was what was the function of this target marker. It is a reflective material which was deployed on the asteroid. And because it was a reflective material, it used as the marker, the spacecraft used it as a marker to navigate itself when it is touching down on the surface of the asteroid. That was the thing. Then we have the small carry-on impactor. Well, this is a something which I'm really excited to talk about. I'll tell you about that in a bit. Then we have the infrared imager, small monitoring camera, and some other. So this is also one lander. This was the lander. MASCOT is a lander, which is a German and French built lander, you can say. Then we have more scientific instruments, the optical navigation camera, and ONCT, the optical navigational camera, telescopic. So these are some uh, instruments, and basically you can say uh, what Hayabusa spacecraft is all about. That's the thing. Okay, now we can have a look at the Hayabusa spacecraft, Hayabusa payloads it has. Hayabusa spacecraft itself has a deployable payload, so we can have a look at that. So this is a pretty good image which we can see. As you can see here, this is a pretty good image. So uh, at the top, these three thing, yes, which you are seeing here are the rovers. Now you will ask me like, okay, these are rovers, but we don't have any wheels, rolling surface, rolling equipments or something like that. Yeah, that's the thing. They are the rovers, but they don't have the wheels. Yes, that type of rovers are also possible, because on asteroid Ryugu we have a very 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 less gravity, and that's why we have the wheels, but you can say the wheels are inside. We have the reaction wheels which are inside all these three rovers, which is used to rotate and hop on the asteroid. It does not basically have wheels to go here and there, but it hopped on the surface with its reaction control system which is there inside them. So yeah, it's a pretty good thing to know, right, how these things work. So these are these are the three one. What was the name of that? We have Minerva. Yes, Minerva 2-2. This is the Minerva 2-2. This is the Minerva 2-1. Okay, then we have this MASCOT Rover. This is also a rover, or you can say a lander. We mostly a lander because it didn't perform much of hops on the surface, but yeah, it landed on the surface successfully. Okay, that's the thing. Then we have this sample return capsule. This is how it looks like. There we have the heat shield and many other thing. Then we have this. Wow, this is, you can say, I would like to say it as an anti-asteroid something, anti-asteroid missile. Okay, a small anti-asteroid missile. Basically, yes, what this is what it does. In theory, it has one copper projectile in it, and it actually, when the uh, it was separated from the spacecraft, it actually projectile one copper, it actually, yes, a projectile, one copper projectile onto the asteroid surface at a speed of 2 kilometers per second. Yes, there is some explosive part in here which actually propelled that copper projectile at the surface at a speed of 2 kilometers per second. And why did they do that? They did that to expose the inner surface of the asteroid and to collect that surface, because the surface which is above the asteroid, which is basically the first layer of the asteroid, is you can say is hit by radiations, other effects of the galaxy and everything. But for the inner one, they are like very fresh, so that's why it was used. Then we have this deployable camera. This is also a camera which actually recorded everything which was performed by this you can anti-asteroid projectile, you can say that. Because obviously the problem was when it hit the surface, uh, everything just went like, you, if you have seen the Osiris Rex imagery, then you must be knowing that when the anything hits the surface of the asteroid, how the sand, the gravels or whatever it is, how they just spread in all directions. To protect the spacecraft which is there, it had to perform a maneuver which actually took the spacecraft to behind that impact point. Okay, I'll show you what am I talking about. So since it was behind, so it was not able to capture the images, so that's why a deployable camera was there to capture that. Okay, then we have these target markers. Okay, so these target markers have the role which is in their name, to basically have provide navigations marker to the spacecraft. And these are the small spheres which have was coated on a in a reflective material, so the spacecraft could um, see that. Yeah, that's are some payloads which it had. So it's a pretty complex mission, and I have so much to, seriously, so much to talk and everything. I mean, wow. Just be with me and I'll tell you everything. So okay, that's the thing. Now this is the real image of the rovers, you can say, the Minerva 2 1, Minerva 2-1. They were placed inside one capsule kind of a thing. These two rovers were placed inside one capsule. And yeah, these two rovers, uh, if you ask me what was the purpose of these two rovers and what scientific instruments it had, these two rovers had a wide angle camera, a stereo camera, and thermometers. Okay, so wide angle camera, you know, as the name suggests, it's understandable. But what is a stereo camera? Stereo camera is used to image three used to have a 3D image of the surface or whatever it is looking at. That's the role of the stereo camera. So these two have that. And yeah, they had a successful landing, and they both operated the rover 1A, one of the rover operated for 36 days, and one of the rover operated for 3 days. Okay, so that's the Minerva 2-1. Okay, now we can have a look at this thing, the Minerva 2-2. So this is the second rover which they used, and this had instruments like two cameras, thermometer, accelerometer, optical and ultraviolet LEDs for illumination. But the problem was this rover failed before the deployment happened, and so it was just released in the orbit of the asteroid, and it mapped the gravitational uh, it took the gravitational measurements basically before it impacted on the asteroid few days later. So this was the failed one, but yeah, it's okay, nothing major happened because of that. Then we can, this is how it looked like if it everything was successful. This is a CGI image. You can see like how it could have hopped on the surface. Then yeah, this is the MASCOT Rover, which was made by German and the French space agency, and it was a pretty good rover, or you can say a lander. It was a pretty good thing because firstly it had camera, it had infrared spectrometer, which usually used to have the measure actually the composition of the asteroid. Then we have the magnetometer and a radiometer. But the problem with this lander was, why am I saying a lander? Because it operated on battery power. It didn't have solar panels, as you can see, like the other one had. So that's why there was some problem with it. Means it only operated for we had a successful lander, and it just operated for 17 hours before it battery ran out. Okay, so that's the thing. Then we have this is the CGI. You can see that this is how it looked, how it would have looked like. Then we have this deployable camera. So this deployable camera, you can see and have a look at it. So this is how it will have looked like, this deployable camera, which actually recorded the event when the impactor hit the surface of the asteroid. Okay, so yeah, this is the sample horn, which is actually which extends and takes the samples from the surface of the asteroid. Okay, then this is the obviously the sample return capsule, which is now returning back towards the earth, and it has the samples from the asteroid. Okay, that's the thing. Yeah. Okay, so we missed something, and we missed this one. Yeah, this one. These are the surface impactor. This is how the impactor looks like, guys. This is the impactor which impacted the surface of the asteroid. It has explosive material in this part, and it projectiled what was the dimensions of the projectile? Just I'll check, I'll tell you. The yeah the A 5 gram copper projectile was, you can say, fired at three. No, 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 not that one. Just a sec. I don't know. It's, yeah, 2.5 kilograms copper projectile. Yes, it had a 2.5 kilograms copper projectile. So yeah, that's the thing. Then these are the target marker. This has the antenna, as well as you can see the reflective material, which is used to navigate. You can say navigate on during the touchdown on the asteroid. And this is the sample return capsule. Okay, so yeah, that's the thing. Wow, man, we have so much else to talk about, and the stream is about to start, so I'll try to cover it properly. Guys, if you like the stream, whatever I am saying, and if you are liking that, you can just give a thumbs up to this stream. Subscribe if you haven't, because on this channel I host live streams of every rocket launch that happens in the space industry, as well as other space related events, as well as some other space related flight related videos and everything. So you will find everything on this channel. So it's a one-stop solution for everything. You can just subscribe if you haven't till now. And if you would like to support me, you can always support me on the Patreon. Link is in the description if you like my work. Else, super chat is enabled. If you want to give a one-time donation, super chat is enabled. That really helps the channel to be and deliver this type of content to you. Okay, so now we can have okay, so now we can have a look at what the images the rover actually took. Okay, these are some of the images which the rover actually took. Yeah, this is the moving on Ryugu when it was hopping. So that's why it's blurry. And this is the surface image which the rover took. Rover didn't had any high quality camera, but yeah, whatever it had, these are the images which it took from the surface of the asteroid. Okay, and rover 1B has this images, Hayabusa2 Ryugu. Okay, and it is hopping surface of the Ryugu. 1B hop. These are some images. Yeah, it's blurry, but now this was the my favorite image, because you will see in a bit why am I talking about surface after landing. These are some high quality images from millimeter distance. So yeah, it's pretty good to see all these things. Now this one, successfully shot a movie. Here you can see the sun is moving, and we can see a beautiful imagery which was taken by one of the rover. This was I was talking about, and I liked it so much. So yeah, that's the thing. Okay, so now this was the images and everything which happened, which 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 like you can see. Now we can have a look at what was the sampling process actually, and what it actually did. So for the sampling process, I mean, it had to take three samples. It was the original design, the original mission had to take three samples. That's why the sampling capsule, you can say, had three compartments in it. The first this And now the samples also had two types of samples it had to take, the surface sample and the subsurface samples. Okay, and for the surface sample, it had to take surface regolith that exhibits trait of hydrous minerals, and the surface regolith with either unobservable or weak evidence of aqueous alterations. Okay, so it originally planned for two surface sample, but ended up only taking one. And that one sample, basically, what was the mechanism it took to take that sample? It take the sample by, obviously the spacecraft descended on towards the surface of the asteroid, and then the sampler horn, which is attached to the Hayabusa 2, underside the touched the surface. Then a 5-gram projectile was fired at 300 meters per second into the surface. Now, because it was fired into the surface, there was some particles which rebounded from the surface, and those particles were collected on in the surface sample capsule. That was the thing which it took from the surface sample. Okay, now talking about the subsurface sample, but before talking about the subsurface sample, we have the video also of the sampling process, so we can have a look at that. Now this is the video we have. This is how it looked like. If you have seen the Osiris Rex, this actually so much is similar to that of Osiris Rex imagery, right? It just went there, projectile, fired that projectile, and then came back. So yeah, that's the thing. Now sampling, this was that. Okay, oops. Now this is the one which I was talking about. Okay, surface sampling impactor, the impactor which it had, and I'll explain you in a bit. This was the second type of sample which the spacecraft had to take. So for that, it fired a impactor. As you can see here, it impacted the surface of the asteroid. Then the spacecraft came back again. Then it touched down on the surface, because now it has a fresh layer of the sample which it can take. And again, the same method was applied. For taking the sample, the projectile was fired, and then it took the samples. So why this hit the impactor hit the surface? To reveal the inner surface of the asteroid. That was the thing. Wow, I mean, yeah. Now we have the imagery for the third sampling process also. This is the third sampling process. Third, it's second sampling process, means the second touchdown of the asteroid Ryugu. Very similar to the first one, but yeah, the site which it took for sampling was a different one, and it had different resources in it. So yeah, that's the thing. Now everything I have covered about the spacecraft, the payloads and everything, the sampling process and everything. Now finally, we can have a look at what it will be, what we will be seeing now, the recovery process. Wow. Okay, the recovery process. So this is the recovery process which we can see here. Yeah, so for today, actually, today or yesterday, whichever time zone you are living in right now, it performed these maneuvers, TCM0, TCM1, TCM2, TCM3. So it actually is departed the after taking the samples, it departed the asteroid in November 2019, and it arrived here, as you can see, no, in December 2020. And before arriving, it performed these maneuvers just before landing the capsule. So for that, it performed, TCM is nothing but uh, correction maneuver, transfer correction maneuver, if I'm not wrong, which it performs. And it has ion engines for that. So this spacecraft does not run on chemical engines, but it has ion engines. So it's, that's electrical propulsion it does, and that's why it has you know, I mean, more specific impulse as well as more life to the spacecraft. So it performed TCM0, TCM1, TCM2, TCM3. So if it didn't have performed any TCM maneuvers, it would have just gone like this in this blue line and passing at altitude greater than 200 kilometers. Since it performed these maneuvers at TCM3, as you can see, till TCM2 it was orbit fine adjustment, that's it. Now at TCM3 it targeted towards the Woomera side of the Australia, and then at TCM4 it again had a orbit fine adjustment, and then finally the capsule separation happened at around 12:15 or 14:15 JST, 2200 2 lakh 20,000 kilometers from the earth, or 220,000 kilometers from the earth. And then this was an important maneuver which it had to perform, the TCM5. If it hadn't performed this maneuver, this spacecraft would have, the Hayabusa spacecraft would just enter the atmosphere like the re-entry capsule. Since it separated the capsule, so capsule is in trajectory towards the Australia, but since this was also a successful maneuver, the TCM5, it successfully changed its trajectory to come out of the this Earth's atmosphere and escape trajectory. Since it was at escape velocity, so it performed just a flyby out of the Earth and into the deep space. Okay, so that's the thing. Now we can have a look at this thing, the separation of this is, you can say, what will happen in after the separation of the capsule. Since when the separation of the capsule will occur, it will be separating with the rotational speed of one rotation in about 3 seconds. Okay, so it was 3 minutes or 3 seconds. So this rotation is useful and is important because you can say when it enters the atmosphere, it transfers the heat from to various parts of the capsule. It does not, if rotation didn't happen, then all the heat would have hit just one part of the heat shield. But since it is rotating, so the heat shield is also changing the surface of which is being exposed or something like that. So that's why the and re-entry effects are reduced when it is rotating. That's why rotational is there. Then re-entry starts at around altitude of around 200 kilometers. Then aerodynamic heating is happening, so we will see a fiery entry of this capsule. And then we will have a re-entry speed will be around 12 kilometers per second. Then we'll have a parachute deployment at 10 kilometers per second. The heat shield will also separate, which will expose this beacon antenna, and this parachute, which will deployed will have a radar reflective cloth, hence it will be easily be able to know where it landed. And then we have the beacon antenna, which will obviously transfer the signals of land, exposing the locations, and yeah, those things. Now if you ask me what is the location of the landing, this is the location in southern Australia, somewhere here. This is the Woomera desert, where here it will be landing. Woomera, this is the thing. And the you can say it won't be a pinpoint landing obviously, so they have a 100 kilometer by 100 kilometer square target where the capsule is expected to land. Okay, then yeah, they have this also. I had something to talk about for this also, but I think the streams have started. They had a very good recovery operation also. I mean, how will they recover? So but think I can skip that for now, and we can have a look at the streams which is already up. And guys, just one interesting thing to note about is this: the Hayabusa mission is not over. I mean, Hayabusa 2 mission is not over. It has been extended after the successful separation of the capsule. Okay, that asteroid mission is completed, but the Hayabusa 2 spacecraft, since it performed that TCM-5 maneuver, which changed the trajectory to have a flyby of the Earth, so that's why its mission duration is extended, and now it is you can say expected to last till 2031. Yeah, and at that, until that time, it is expected to perform a flyby of the asteroid 2001 CC2, which will just be a flyby. And they think that will be a very difficult to capture, not the capture the images also, and do the scientific experiments. But since it is a flyby, that's why. Then after that, they are planning to do a 1996 KY 26, I don't know, 1998 KY 26 asteroid. That is what they are planning to rendezvous with. Now this is a special asteroid because this is the asteroid which is only 30-meter wide, and this is a very small asteroid, and will be trying to rendezvous with it. And when this, as you know, the mission duration is 2031, so they have 11 years, and they will be having very much time for coastal phase of the this Hayabusa 2 spacecraft. For that, at that time it will study the celestial glow that travels in the universe, as well as the exoplanets. And yeah, I mean, this is a really very complex mission, and I'm really very excited about these missions. So I had so much to talk about, but now we can have a look at their um, I mean, okay.
This is made of copper. And I was engaged from launch and initial operation. Next presenter is Mr. Isana Kashiwai. I am a science writer and web engineer.
And guys, if you are wondering as in what will be the amount of samples they will be retrieving, they have not released the amount, but it won't be like kgs, it will be in somewhere around few grams, 5 to 10 grams of samples. Yeah.
And also today's you can see a countdown script. Actually, this was built by me. And you can see some number. This is a time before until the re-entry. So if it's counting down to 0, then if this is 0, you can see a fireball.
And another one is real-time 3D screen will be shown. That is, I'm making, and already Hayabusa has been.
So yes, they had the timer of the atmospheric re-entry, and I have the timer of landing. So that's why that is different.
Therefore, I'd like to look forward to seeing the re-entry of the capsule only. And for me, actually, I am science communicator Yuko Okayama. And please enjoy this live distribution up to the end of this program. And actually, Mr. Hosoda supervisor is in the control room, but now we are joined in the studio. Mr. Hosoda. Well, actually, I'm the supervisor of Hayabusa project, Hosoda, and already I have finished the supervisor, and now I am one of the project member of this Hayabusa
And
2 project. And after that, I will go back to the control room and
why did they choose this landing, Australia landing? Obviously because Japan is very small to pinpoint. That's why I think they chose, and then after that they will fly the samples back to the Japan.
simultaneously interpreted English version is also provided.
XP, that 20-minute countdown is the before this hits the atmosphere, and I have that 40-minute countdown that is before it lands. Means I have a landing countdown, they have the re-entry countdown.
Station staff in the Hayabusa2 ground station, and this was made possible by the cooperation of summary writing group Momiji. And actually, it was quite impressive. The Hayabusa 1 came back to Japan, and we celebrated the return of Hayabusa with cakes and lots of flower bouquet, and also with lots of smiles. This was 10 years before, however, still everybody remembers that.
And guys,
Today
if you are like why are they collecting just a small sample, so let me just tell you that scientific community have can work with a little as some few 0.005 grams. Scientific community can work on that sample also. So it's not like they need a large amount of sample, but obviously large amount of sample have their own advantages. More experiments, and you can say if something gets wrong, they have also a backup amount of samples left. But yeah, the amount of sample which they are getting, it's all right. It's not a very big sample, but yeah, that's enough for scientific research.
Please let us know the condition there. Currently, actually, you know, the sky, in the sky, there are lots of stars in the sky, and we are so much relieved to see the sky.
And yeah, I think
we have been expecting a lot.
They will be showing the re-entry fireball also, if I'm not wrong. That would be so cool to watch.
Came into the Umela, you know, we have been paying attention to the weather forecast so much. However, yesterday morning,
this is a sky. This is just a sky which you are seeing, and we are expecting a fireball to come when the separation capsule will re-enter the atmosphere.
Having the best weather since we came here, and actually, you know, even the weather did not betray us, did not betray our efforts.
Let's hope, John, we see that.
The great shoot of Hayabusa 2. And anyway, we are waiting for it. Come on, Hayabusa capsule.
Asteroid के orbit के बारे में that is around the Earth, not the Earth, obviously. Sorry, that is around the Sun, which I can tell you about. That's a near Earth asteroid, and it is around the Sun. Yeah.
Miraculously, we are having a very good weather, so I'm so much happy to hear that. Then, I'm so much expecting. Thank you. Well, you said that there are lots of stars in the star, but there is no light in the town, therefore you can see so many stars. Yes, there are so many stars, and even moon is shining very brightly. Actually, I never knew that, you know, the moon can be so bright.
Wait a sec. I think this is a.
Today in Sagamihara,
I can't even get their translations
it was
properly.
Cloudy for a long time, but at night, you know, actually, now we can see the stars and even moons. It's we are seeing the same moon, right? We are sharing the same moon. Yes, that's right. Actually, as advised by Mr. Okawa, the moon can be such bright. Yes, this is Okawa, and actually, we can see many stars. Well, it's quite, impressed because you have a great weather at that. And can you see Milky Way
This is the English
visually?
translation which we have, but they have a, I mean,
Right before
the accent is somewhat problematic. That's the thing.
very clearly. However, now because the moonlight is too strong, therefore we can't see Milky Way very well. Oh, I see. The the moon is too shiny, right? Is that right? That's why you cannot see the stars very much. Oh, I see. That's right. However, we believe that the capsule can be seen very clearly. Yes, we will expect that. And lastly, how about the wind? In the daytime, we heard that it's a bit windy. Well, it's not very strong. Oh, I see. Well, it seems the condition to welcome the capsule is kind of perfect. Yes, everything is perfect to welcome the capsule. Okay, let's go back to the studio, and we'd like to have some talk about operation, and also let's review the separation of the capsule. Mr. Imamura, please.
Yes, this is a miniature mark, and this is presented by Nihon Koki. Thank you very much. Now, we would like to review what we did today. And during daytime, we did the capsule separation, and the Hayabusa2 escaped the Earth. To do that, we did the trajectory correction, and the capsule is now under the shadow of. That means the Hayabusa2 is the shadow of the Earth when viewed from the sun. So, since there is no solar light, so it is moving based on the battery. And it's the daytime, Hayabusa2 finished taking pictures, and the capsule already entered. We are going to show you the entry of the capsule and the fireball. And this is a sequence. Hayabusa is heading to the Earth, the change attitude, capsule separates, and it's escaping. It's not
Yes,
raising
Mac,
the
I need a
Earth.
new microphone.
So we
The
have
audio quality is
finished
pretty
so far.
crappy.
And this is how the capsule is.
So if you can support me, you can do on Patreon, as well as if for one-time support, super chat is always enabled.
This Okayama, the telescope at Okayama, and actually this is a video of the separation of the Explorer and the capsule.
At 16 inch or 40 centimeter in diameter.
This is the image of the telescope. The center is a capsule, and the left side is the Explorer.
40 centimeter is the dimension.
To see. So next one is a movie. Yeah, here this is a capsule, and this is the Explorer is moving away. The capsule is still at the center.
We are 10 minutes and 30 seconds from the re-entry to start. Guys, this is happening now.
Here is 20 centimeters per second, relatively. And that means we were able to capture this from the ground. And also from the National Astronomical Observatories, they say that they had take pictures and movies. And can you go back to the slide again? And the capsule is like this.
今この形で、回転しなが
Yeah,
ら、
capsule
飛んでいます
is now flying in this state.
3秒間に
It's
1回転
rotating.
ですね。
It's
で中に
one
はこの、
rotation per
サンプル
second.
コンテナが入ってます。
And
大き
it
さとしてはカプ
contains
セルの大きさと
sample
しましては、
container.
直径
And the
約
size
40
is 40 centimeter in diameter and 20 centimeter in height and 16
こ
kilogram.
れが分離して、背
And
面
this
ヒート
is
シートと、
separated.
前面ヒートシー
And
トと、あ
this
とは、
is
コンテナ
separated to
サン
the
プルの入って
back
る
heat
インストゥルメン
seat
トモジュール、ここにパラシュート
instrument module with
最終的に
parachute.
は3つバラバラ
And
に、
this is separated into 3
降りることになる。
parts, and 3 landed
で具体的にどういうシー
independently.
ケンスで
And the
スピンになるか
sequence of
ちょっと機械で説明
landing
させていただきます
is
と、今
shown in
約
this
3秒に1回転
illustrations.
のスピンで、
And now this is spinning
分離
once
回転し
in
ながら
every
5000
3
よりも分離
seconds,
されております。
and it has
5000
already
自体
been
は回避
separated,
マヌーバーをして地球
and the Hayabusa 2
圏にぶつから
has
ない
already evacuated,
新たな目的地に行ける
and
ように
it's
もマヌーバーしております。で
and
そこから
maneuver finished,
再突入をし
and
ます。
it
高度
will
約
now
120
re-enter the
キロ最後はまあ
atmosphere
速度
at
約
about
11.6
160 kilometer,
くらい。
and the speed is 11.6 meter per hour, and the density of the air increases, so the friction occurs and aerodynamic heating occurs. So the speed is decreased and to almost the same as the speed of the sound. It's around 340, and the impact wave,
動的に不安定。
and it gets motion gets unstable,
そこをこの姿勢のまま乗り切り
and it is continued this posture.
0.1km
And when the speed goes down to 0.1, then heat shield is separated at this point,
主に3つのパーツ。
and it's separated into 3 parts, as I explained
真
before.
ん中のところですね。
At the center
These
portion,
things I have already explained you guys, so you must be getting it properly now.
and it's
Boy, we had so much to talk about it.
10 kilometer.
この後風の影響を非常に
And after parachute deploys, it's affected by wind.
開いた段階でここの下にあるこの出ている
When the parachute deploys, this is beacon antenna. So the beacon transmits a signal, and the ground station receives it. Then it can identify the direction. And the helicopter uses this information from this beacon. And in case there is no beacon signal, and there is something on the parachute which reflects the radar beam. The Mari emits radar beam, and it reflects, and we can identify the distance.
インストゥルメントモジュールが地面に着地しま
And
した
when the instrument modules landed,
間接的に継続的に
and still beacon transmits signal,
出し続けると
not continuously but intermittently.
間欠的に出すという形をしております。はい、であと風で飛ばされないようにこのパラシュートを
And the parachute will be detached after it's landed to avoid the capsule is moving. And this is the time and altitude of the sequence. And at 2:28,
もうすぐですね。
and
はい、
it will be very soon.
下級フェーズになります。
So we can see a fireball phase.
10キロまで
So the altitude
下がります。
down from 120 to 10 kilometers. It takes only 3 to 5 minutes. And at 10 kilometers parachute deploys, it takes another
でこの着地する
15 to
先はどこかと言いますと、まあ
25 minutes.
南の方
And it is going to land Woomera area in the southern Australia. And we use various methods to identify the location. And this is the expected landing area. So TCM3, after TCM3, the area is 150 kilometer to 100 kilometer. Then this is ellipse expected area. You can see surrounded by blue line. So the capsule is expected to land here.
では管制室の方 たい。
Let's go to the control room in Sagamihara. Okay, this is Hosoda. And let me report the status of the control room as for the Hayabusa2. Currently, actually, at 1:56, it's entered the shadow part of the Earth. And from that, for the time being, we cannot see the explorer. And now, the atmosphere in this control room is a bit
Oh
nervous.
man, this is happening, guys. It's around like 5 to 6 minutes until it enters the atmosphere. The capsule
Thank you
enters the
very much.
atmosphere. This is happening for real. I mean, I'm really excited for this. We are living in such a good time now. These all things happening in succession. The Chang'e 5 also is, docking is in process now. So let's hope that is also successful.
It's kind of ready to see the fireball. Yes, that's right. Mr. Hosoda, thank you very much. Well, it seems the capsule will re-enter the Earth's atmosphere, and from Australia, Cuba, Perry, we will have the live distribution. Now we can see here, for the time being, until the fireball comes, would you like to have some report in Australia? Well,
And 3 minutes until it enters the atmosphere. Man, this is happening so
the
cool.
night sky, and
Wow.
we can see some stars.
Wow.
I'm checking.
We are just checking the skies also for the fireball to happen. I am so excited. Wow.
Stars. When you see, the brightness of the star is a bit different. Actually, this is wide range camera, and this is probably the first level star, and this camera is showing the first grade star. It means that if the fireball's level exceed this level, it should be easy to identify it. But how about the brightness of the
Guys, the SN8 hop is 12.5 kilometer, and since it has reduced from 15 to 12.5, that simply means the rocket won't go transonic.
it should be different.
So they are going one step at a time. So let's focus on this right now. We are T minus 2 minutes from the capsule to enter the atmosphere. So guys, let me just tell you one thing, that the parachute deployment as well as the heat shield jettison is fully automatic. Nothing will be in control from the mission control. So I am really hopeful that that process happens correctly, because we want that to happen correctly, because no command will be given from the mission control for the parachute deployment, and if it is somehow the automated system fails, then wow, no, nothing can happen. So that's why let's hope that is correctly done and we can have these samples written successfully.
Actually, it should be the brightest star, even from Sagamihara. This is a fixed star, and this is minus 1.5 magnitude. Therefore, fireball should be much brighter. According to Mr. Shirai, moon is very bright. Therefore, bright moon and another very bright fireball can be seen in the sky. Well, actually, we are not catching the images of the moon, therefore it's out of
Guys,
range of the
30 seconds since it enters the atmosphere, and after some few minutes we will be able to see the fireball coming in. Let's hope.
Now, actually, this moon is not this area. Actually, this. We are seeing the anyway Sirius and Orion, and also Eridanus, which is not really
And
easy to see
now
from Japan.
is the time it has entered the atmosphere. And Mission Control Center can do nothing about it because now let's just see and watch and wait everything goes correctly. Wow, it's happening. Now 23 minutes until that thing touches down. Are we seeing something?
If it comes from which side? If we see from Kupapeti, it should come from nose.
Is it
west.
coming?
Okay, it's
Yes,
coming
we
from
can see that.
right side, and it's
Wow,
getting
wow,
brighter
wow, wow.
and brighter, and the speed is very, very big.
And we can see
And
that
it
trail
is
also.
coming through near the zenith. Okay, it has gone.
It has gone on. I mean,
No more lights in the sky.
okay.
Anyway, re-entry was made, and it was confirmed by everybody. Well, 6 years, and finally, it has come back to the Earth, and all the people in the world were waiting for it, waiting for this moment. It was rather slower than we expected. And therefore, anyway, we could say it quite slowly. Well, the speed of the re-entry of the atmosphere was quite fast, but actually, if it is, regarded as a natural shooting star, comparing to such star, a bit slower. Therefore, it was a rather slower shooting star. Yeah, I should have wished something. Yeah, can we have a replay? Actually, it was over fish lens, and the range was 180
I think they are
degrees.
very happy, so we can say this mission is going successfully and nominally now. Wow, man.
West, and it came anyway from the right side, and in the
We could see that it was like a shooting star. Yeah, as they mentioned, a slow shooting star. Wow.
big laugh.
This is from control room at Sagamihara, and there was a big applause.
カメラをオンして、探査機の方から連射していると。はい、その結果はまだ。
And actually, the camera is on, and Hayabusa is taking pictures. And I understand that everyone is pleased. And also, I hope that Hayabusa took pictures of fireballs.
非常に風間が完成です。非常に皆さん喜んでいたんですけど。
And I understand everyone was pleased. And the Capsule team members and go back to the desk and watching it. Yeah, but from now, it's time for Capsule. So whether the Capsule is separating or not.
What happened?
What's this applause? What's this?
確認しています。少々お待ちください。
Wait,
Is it the parachute deployment?
I'm not checking what it is. Maybe shields separated. I think it's the time of deployment of parachute. Is there any report? Maybe some report? Yeah, someone raise a fist. Hosoda-san? It seems he is now checking.
They are checking and we will be knowing.
相模原管制よりスタジオ。
Yeah, this is a control room at
現在の
Sagamihara.
みんなの喜ぶ理由ですけれども。
The reason why they are so pleased was, yeah, they received the report of the beacon. Yes, so beacon received the transmission. They said that they received in Australia. That means the beacon is received. It is, but still that we are not able to identify the place. but it means separation and parachute deploys and it sends transmission.
何箇所かでビーコンを
Symbols.
Ah, okay, I got
And
it.
that means these beacon signals are
方
received.
向が分かりますのでこちらの方向
Actually, the beacons are received at several places, and we can identify the direction.
Actually, guys, the beacon signal they are getting, that's what they are saying, which means the heat shield has separated and it has exposed the beacon antenna, and they were getting the signals from that. So that's why they are happening, means parachutes were deployed successfully, and I mean their mission is success now, and they now just have to locate it.
こう捉える位置としてはですね、
So
砂漠の中にこう地点に
this time there are 5 sites where
これ
which receives the beacon signals.
ここからやってくる電波を
That's so that they can receive the wave from different directions, and that helps identify the location of capsule. So this is based on a triangle
よろ
measurement.
しければスライドを映していただければ
Can you show me the slide? Yeah, this is direction
こ
finding.
のような方向を探索するアンテナ
Yeah, this is antenna for direction finding. This is after antenna is installed. We have installed 5 antennas at 5 locations. Each of the antenna receives the
ビーコンが受かったか
signal, and if each of the antenna understands the direction, so we can see the crossing point. This is where the capsule should be.
してませんので
But it's now still the flying, not landed, so
動きながら
it is moved by wind
出る状態ですので
and still continue moving.
交点がいろいろ動いて
So it seems that the crossing point is also moving.
こう回転
The antenna can rotate in the horizontal direction, yes,
強度の強い方向でこちらから電波が来てるっていうのが分かります
and the antenna faces the wave.
現地で、それぞれの場所で、
はい
私のところからは南度の方向
So each antenna
Guys,
identifies
the mission is successful. Now they are just telling you the process of basically their locating of the capsule. They had a successful deployment and it landed successfully. And yeah,
This is
let's see if we have any official confirmation, and I'll update you with that.
depends on the wind.
はい
Yes, it's affected by wind.
今はこの楕円よりも、
And rather than this ellipse, I think this is rather circle, not ellipse, but 150 by 100.
この後回収隊の皆さんは
But after that, what will the recovery team do?
ビーコンが出てるっていうのがこれが一番メインで考えていたやつなので
Okay, so
the
now the
main-
landing has not begun right now. Only the parachute has done. There is no landing. It will happen in around 7 minutes from now. I think so.
But we use
That means that was correct. Okay.
We will fly helicopter to the site to confirm. And also we use the GPS coordinates. The remember the coordinates.
Yes, for the you are right. It around 10 minutes or 7 minutes. It is will be touching down the surface. It's right now flowing and coming down under the influence of parachutes.
Backup method. It's likely.
スタンバイしてる人たちも皆さん
Thanks,
But I
Richard.
think still
Yeah,
the
that's what.
Backup members still continue measurement.
一度リプレイを見てみます
So shall we replay? See the replay movie?
はい、画面の右側
Now
が
from the right side is northwest. So from the low place, the light is moving.
Yeah, this is
This is
the
a capsule.
guys. This was the fireball you can see here. Let me find one better visual. I got some better visual also, so you can see that also. Let me see that.
That means this is because it's closer to the observatory area, the speed.
少しこう尾を引いてるような
Actually, it's something like a kind of tail. Don't you think so? Anyway, this is called afterglow, and this, in case of the natural shooting star, there is such kind of tail remains. Such kind of a phenomenon was observed.
オーストラリアではどれぐらい
In
の人がこれ
Australia,
を
how many people were actually watching it? Oh, now we can see, afterglow can be seen very well. In several seconds, it will return to the dark one, but anyway.
これは肉眼で見ていたら
If visually we see it, the brightness will not change very much. Yes, of course, the brightness around the capsule is very bright, and comparing to that, the tail parts should be much lower. However, even with people's eyes, it could be seen, and actually. Comparing to the first magnitude star, if you can see lots of stars in the sky, even the afterglow of the tail could be seen with your eyes. This time, in the Cuba Betty, actually, this is, the north side as observation station for this fireball. And actually, there are so many images in various places. And usually, maybe you remember that, the fireball flew from left to right. And that means that, the observation site was different. And actually, as for this time, the fireball came from the north side. That's why we could see the fireball moving from right to the left. Here is a Cooper belly, and here is we can see the fireball. That's why we saw from the north side. Yes, that's right. And this time, long way was observed, and the position for the observation site was so good. And
Guys, let me just have you. We had some other visual also of the fireball. Let me just let me share it with you, and we can see that now. See this. This was a better visual, guys. Wow. This is the fireball coming in. I mean, wow, 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 wow. And we has just streamed this, and we had a better visual of that. And see this thing, the fireball, the fiery re-entry of the capsule, and it was such a good thing to see. I mean, wow, just like a shooting star or something like that. Wow. I mean, just a sec.
In the sky, but actually it is re-entering to the Earth's atmosphere with the angle of 12 degrees. And the right side is much higher altitude.
How much time will it take? I mean, it will take around 5 minutes or so now.
Around here, this is the zenith, and when it comes to the center, actually the angle is the highest from our observation site. After the lightness, parachute was deployed. Well, probably a little while later, after the brightness, disappeared.
まで少し時間間隔があります。
There is some more time lag until the parachute is deployed.
で開きますのでね。
And because the parachute will deploy about
上空40キロ
at altitude about 10 kilometers.
まあ
Therefore,
見えてるところ、カメラで捉えられてるのはもう少し
and actually, when we were recording by the camera, the altitude should be a little higher. Okay.
届きましたか？
今一瞬アップの映像が出たんですが
And momentarily, we could see, the very much
はい
magnified
今、この
image.
火球を捉えるカメラは
Okay.
何種類かの撮
There
影
are
方法でね、
many
展開されて
ways, and so many cameras were deployed.
準備が
Therefore,
整えば
if they are ready, they get ready to send it, I'm sure we can show it to the audience. And the magnified images, actually, that camera could be following the moving fireball. Therefore, as soon as we get that image, we'd like to introduce it to you. When you said that, that after re-entry, suddenly the speed will slow down, and it's kind of difficult to see. Yes, actually, we can see the fireball from far away, and from 60 kilometers from the observation site, such kind of, the distance is seen as a difference of the brightness.
出ました。カラー
Yeah,
です
here
ね。
it is, colored.
見事にたくさんの星が
And we
Wow.
can see a lot of
Just
stars.
see that follow. Oh man, I didn't. This is a better visual, man. This is what we want. A high quality camera and everything.
And the light emission finish.
This is so good.
And it's gone from the
これは
screen.
より画角の狭い
And
望
this
遠
is used
に近い
telescope
レンズで捉えていると思われます。
We won't be seeing the landing cannon because the thing is we don't know the actual landing location. The landing is around the landing area is around 100 kilometer to 100 kilometers, so somewhere in there it can land, so they have to find that.
これまで
And
regarding
obviously it's the night time there, so yeah.
the
方
website.
からの応援メッセージが届いているんです
And
が
also we
そういった
received
方
a
では
lot of
カプ
cheer
セル
up
に関して
messages.
玉手箱
So some people say that this capsule is a treasury box,
世界の財産
a souvenir, a treasure of Japan, or asset of the
12
world.
月なのでクリスマスプレゼント
And also some people say that this is called as a Christmas present since this is December.
思い思いの表現から
So from these expressions,
心待ちにしている
we
という
learned that many people are
気持ちとそうした気持ちと
looking
大きな期
forward
待が感じら
to
れていたわけなんですけれ
return
ど
of
も
this
し
capsule.
っかりとその期待に応えて
But
着地してくれてればいいなと
I hope that the capsule landed
相模原管制から
will land.
お願いします。
先ほどのよりの
Yeah, this is from Sagamihara control room, and there was another yell looking at the
本当に
image.
カラーで綺麗に
Should be
So
landing
that was
now at
very
any
good.
time now, guys. It should be landing at any time now.
Camera, yeah, because recently,
ね素晴らしい画質
even with this high sensitivity, the quality is also good.
であと火球そのものをねこう追尾
And this is like chasing the
おそらくね
fireball.
こう火球を画面の中に捉えながらこう
So
カメラを動か
that
して
means
火
the
球の動きを
cameraman moves the
見た
camera
ということになるかと思います。ね、光の点の中に確かにカプセルがあって
and there was a capsule in the middle of a light point.
ね、確認の時が近づいて
And
まあ
I
ルーから
think-
帰ってきたと思うと
If I think that this has returned from Yugu, I have some
The
special
landing
feeling.
should have happened now. We are just waiting for the confirmation if it has happened or not. Whether they're getting the beacon signal or not. And guys, let me just tell you one thing, that if they are not getting the beacon signal, then also it could be normal, because it could be such that like the beacon antenna is like entered into the soil, or it has been blocked by the capsule or something like that. So that could be the reason. And this is the fireball, guys.
Near the leakage of
Wow,
this,
see that, see this thing. Why didn't they show this on the live stream? It would have been so cool.
this is very high and near the zenith.
Wow. So it fades away, right? When it enters the thick part of the atmosphere, it fades away.
Bright stars. This is the alpha and beta of the Centaurus. The both are the star of the first degree of magnitude. Altaurus is actually the closest star to the solar system among the bright stars. I said it's close, but it takes 4.3 light years. Why you, Mr. Okawa, you know the constellation just from this image? Yeah, because this is my hobby to watch stars. Yeah, this is a control room at Sagamihara. So people are gathering around the product manager. They are watching, they are seeing Google Earth and discussing where the capsule would land. But beautiful, beautiful movie. Can you show my PC?
I think it's the image of the no, it can't be that. Basically Hayabusa also
I can see it through my PC.
Also has imaged the fireball, and we can have that images also if it has transmitted back towards the earth and they have processed it, because Hayabusa was also like above the spacecraft. Actually Hayabusa spacecraft was also above that during when it was entering the atmosphere. So there can be some pretty good shots from that space also.
The control room. So they were watching Google Earth. This is a map. So just by watching a map, they can expect that they should be there. So everyone says different things. Very good atmosphere. Very relaxed. And there is another image or movie. And this is from control room. There is a big news. From the international station, the station captures the Hayabusa2. Can you show the movie? The ISS is where the Mr. Noguchi has gone and where he is staying. Wow,
I mean, are they going to show that images?
Can you switch to the slide?
Wow. Is this from the space?
It means that from ISS, the fireball could be seen.
ISS, oh well.
Okay, the replay, the image. This should be probably Hayabusa2 itself.
Okay.
Therefore, from ISS, actually, it should be much higher than the ISS. So maybe ISS, they took this image, the facings above.
I think this is the
therefore
fireball.
there is a possibility
Oh
that
yes.
This could be the Hayabusa2.
Hayabusa2, okay.
Well, however, actually, I'm so happy because from the ground and also from the space, the same Hayabusa 2 is being shooted. This is
そうですね、はい、ちょっとカメラの見分け
Hayabusa 2 or Capsule. Sorry, I was too happy. Anyway, in the space,
探査機あるいは
the Hayabusa 2 or Capsule flight is taken, right? That's right. Before this program started,
Um, uh,
actually,
guys,
even when
they
still,
are like
they have
this. We don't know whether that was the image of the capsule or the Hayabusa 2 spacecraft, but I think that was the Hayabusa 2 spacecraft because we didn't see the trails. So yeah, that was the Hayabusa 2 spacecraft from the ISS, seen from the ISS. That was a pretty cool shot too.
and it's fell down, it dropped much lower in altitude. Therefore, before this program started, this image was taken from ISS. In the support message, Hayabusa2 is working so hard, but there is no more Hayabusa2's photo, so it's kind of unfortunate. Therefore, Mr. Noguchi took it. Of course, we are not really sure if Mr. Noguchi took this one or not, but because other astronauts could have been taken.
Is it? I don't know. Parachute has opened. They have caught the signal. Is it? I mean, let me just confirm that.
Landed. And if there is a big news from the Australia, anytime we will let you know. And
No official
here
confirmation
I'd like
yet,
to
but
introduce the preparation done by the capsule collection team. Okay, go back to the slide, and
this is how they will collect the capsule.
Here we are looking for the capsule using beacon, and other than that, we have optical observation, and anyway, we are trying to use these kind of measures even for the fireball. And if there is no signal of a beacon, we have another one, the marine radar system. This kind of system was also equipped, and even if this doesn't work, we have a drone, and if we know that in the area of 100
So guys,
by 150 kilometers area,
I mean, I had to discuss all this, but yeah, they are discussing it now.
to let them take a photo.
No. They won't wait for tomorrow. They are just waiting for the signal, beacon signal. Actually, now let me just tell you. Okay, so since they got the beacon signals from the separation capsule, now they can analyze the Dopplers to see if it has landed or not. Okay. I mean, the Dopplers, since it was moving and then it just stopped, it come to a full halt. Therefore, that beacon signal, if it is transmitting now also, can confirm that yeah, the landing has happened. But since we saw that some hustle was there on the control room, we just can't confirm yet. But let's hope everything is good right now.
So, and after that, it will be sent to Japan by airplane.
JAXA's Japanese channel says so. I mean, let me see if we have the confirmation also from the official sources.
Procedures. And are there any movements in Australia?
Wait a sec. Just
Hello, this is
okay.
Fujimoto in Australia. I'm Fujimoto of Umela.
はい、少し途切れておりますが、
The sound is not very clear, but still we can hear you. Please speak slowly.
はい。カプセルの軌道を DFS で追いかけてきました。
Actually, we traced the trajectory of the capsule by DNS,
これから
and
着地点の推定に入ります。
now we will start the calculation of the landed
ありがとうございます。
place. Thank you very much. DSS is a detection finding system, and actually this is the kind of a system using the beacon signal, and the signal was received. It means that probably the landed position will be calculated, and when the beacon signal was received, there are several lines, and the cross point shows that instrumental module should be located there. Therefore, that's why they will go there. And actually, there is a kind of front heat seat and rear heat seat that is not emitting the beacon. Therefore, there is another way, not really depending on the beacon signal. But anyway, the instrument module has the Ryugu's sample. Therefore, anyway, such kind of measures is necessary too.
It's just waiting for the official sources to confirm whether there was landing or not. I mean, some people are saying that we have the landing, but let's hear from the official sources.
Activity at Umera, and I heard there's movies showing the preparatory work at Umera. I want to show you. And this is Mr. Okawa. I think you remember when you were there. Yes, I remember the desert. Also, this is the desert. We have some low trees and some grass, and it's sometimes rains
and sheep also.
Plants.
Racing to get the asteroid samples. Let's see what are they sheep or what? No.
Sheep or something? This is DFS. And this is rotating. And so that it can identify the direction where they can receive the strongest signal.
This is the drone which they will be using if both the methods fail for locating the visuals of this lander. The beacon as well as the radar method failed.
Yeah, this is a backup just in case when DFS cannot identify it. And also this is used for searching for the front and back side heat shield.
Oh.
Yeah, we could
Hi Labrat, how are you?
This is a different
And
familiar with.
we are just waiting for the confirmation, that's it. I mean, why are they taking so much long? Dopplers could have already told them. I mean, maybe they have lost the beacon signal.
Capturing.
I don't know. Let's have an official confirmation.
And try to extract the capsule location. Now we will move on.
Actually, the thing is, after landing, some preliminary test will be conducted in Australia itself, and then it will be taken to Japan.
Tsuda with me. So I would like to make an interview to Mr. Tsuda. Mr. Tsuda, how do you feel? Yeah, I'm really pleased. At the control room, we do not receive any wave, so we are now relieved and just listening to the report. That means waves are caught, received. That means the capsule have already landed, and I hope the helicopter will fly soon. Yeah, this is a beautiful story. We are also moved and inspired. So we continue working. The next one is Mr. Yoshihara, the capsule collection team. So Mr. Yoshihara, the capsule collection team. It's a perfect operation. Congratulations. So far. Thank you. The capsule is its operation of the last day. So we have been looking forward to today. We are happy because every other member did a very good job, but we under pressure because we also have to do that. Finally, Capsule worked at the end, but still we have not found sample yet. So we need to continue monitoring. Thank you.
じゃあ一旦スタジオに戻します。
So we return the control to the studio again.
はい、ありがとうございます。それでは、
Thank you.
ここで、拡張ミッションの説
And
明を
now I would
させてい
like
た
to
だこうと思います。
explain about the extended
では
mission.
スライドをお願いします。拡張ミッション
Can you show us the slide about the extended missions?
すでに、TCM5 で
So we have
地球圏離
completed
脱
the
に
TCM5.
無事成功している。
So that
で
was
この
we were
はやぶさ
successful
これ細田さんの例えに
leaving
Guys,
the
I
Earth
think
sphere.
they have
So according to Mr. Hosoda,
Richard or someone
It's
can they
like-
confirm? I mean, the official sources haven't tweeted yet or something like that, so I'm just waiting for them to confirm. But I think they are happy. That means it has landed properly.
So what asteroid is it going to?
Yes, the future of the Hayabusa 2. Just listen in now.
26.
で
It was not
到着は
named
11
yet.
年後になります。
And
で
it
大
will
きさが30
arrive
メートルと非常に
11 years
小さくて
later.
自転
The
車
size is very small, 30 meter, and it's
11分ぐらいで一周す
spinning.
るということになります。でまあ
It takes
軌道
only
上波は
10
今 1.23
minutes
AU
for one
という地球よ
rotation
りも少し外側
and
で、方程式は 1.37
radius 1.23 and the
2020
orbit period
So,
So guys,
1.37.
this thing has landed. I can say that now, but they just don't know where it has landed. So that's the thing. It has landed, and I'm so happy it has landed. But they are just locating it now. Now where it will be landing, where it has landed.
11 years later from now.
どれぐらいのサイズ感か
So it said, I said this is
リュウグウがその
small. So Ryugu is as big as this, 900 meters compared to this. This is only 30 meter like this.
で、はやぶさ2
So
が
when
こ
we
の差しを
compare
足し
it
て
with
7で6
Hayabusa2, it's like 6 meters. So compared to 30 meters. So this is a comparison
いうような形
with
で
Hayabusa2.
非常に小さくて
You can see this is very compact and it's spinning at a very high speed. And this is a relation between the diameter and the spinning period. The smaller the diameter is, the spinning period is also small, and this is a long scale,
直径がまあ200メートル
and the diameter is less than 200. And the rotation period is 2 hours in this
実
area.
はまだ人類が
Actually, we have not
そ
explored.
の中の一つであるこの
Then this is
1998
one of the unexplored asteroids.
でその拡張ミッション
And as
Right now they are discussing about the future mission of the Hayabusa 2, which the spacecraft will be continuing as it has not entered the atmosphere, so it is totally healthy now, and will be visiting 2 asteroids, which I already told you.
the long voyage technology and also this
And hi Louis Smith, how are you? And thank you so much for moderating the chats. I really appreciate your efforts, and thank you so much for everything. Yeah.
and actually target marker can't stay on the surface of such kind of asteroid. And for instance, this is aggravated or just, the one rock, we are not really sure and how to handle this kind of small asteroid. And also, it has to be a great contribution for the planetary defense. This is, the significance of the extended mission. Planetary defense, actually, this means that if this kind of asteroid or meteorite crash to the Earth, it's quite dangerous. That's why we have to prepare for that. Yes, that's right. same as Ryugu and this one, KY26, it is moving very close to the Earth, and if the timing is unfortunate, it may crash to
And
the Earth. And actually, as for the small asteroids, there
okay,
are
so for the Chang'e 5, the update is the docking is in progress, and let's hope it is successful.
very well. That is a great contribution for the planetary defense. And if we name this asteroid, maybe the person who found this asteroid has a right to name it. And actually, there is a kind of a group who
Right
like
now, they
to.
are telling about the future missions of the Hayabusa 2. If you have just joined, let me just tell you. They have extended the mission of the Hayabusa 2, and now it will be visiting 2 more asteroids. And one of them is 1998 KY26, which is a potentially hazardous asteroid for Earth, and that's why they really need to, do something about it. That's why they are just going it and studying it. And thank you, Louis Smith, for that €1 super sticker. I mean, I don't know why are you like that. I think that was a mistake.
I'd like to talk about our campaign. Please go back to the slide.
I mean, this mission was actually launched back in 2014, and now it has been extended to work till 2031. Wow.
See the little prince of the star. Actually, I was forgetting to write my name, but maybe probably the people who took part in this campaign should remember your name. Your name and the message were actually written on the memory of the target marker 7. And if you go to this page and if you enter your name, and you can know that your name is written here. And what is this shape then? Actually, this is the shape of the target marker. If two ones are kind of overlapped, actually this kind of outer seat, your names are written, and also Capsule is equipped with memory, and in that memory, it has the same names, and that memory has come back to the Earth. And if you remember that you applied for it, please access to this site.
Okay, so your names have come back to the earth if you have applied for. I didn't, so okay, no worries.
It really has come back. There are so many such kind of messages. Yeah, it has really come back. Regarding the target marker, absolutely, the target marker landed on Ryugu. And some of them are staying on Ryugu, but the messages are in the capsule, and that came back with the capsule and came back to the Earth. That's right? Yes, that's right. It has come back. But however, there is
Thanks.
one.
Yes, Louis Smith. I'm telling you, I can't do now. I can't imagine streams without you as a moderator. You are doing such a great job. Thank you so much for everything, Louis Smith.
The rotating around Ryugu, and another one is still attached on the Hayabusa. Therefore, therefore, anyway, the remaining one will travel with Hayabusa 2 for 11 years, and it will go to the KY26. Anyway, what to do is, the later we'd like to discuss. Anyway, with curving our name one by one, the people who enter this project should be kind of feeling one of the family members of Hayabusa. And also, there are so many support messages that, the Hayabusa is something like, the family member of those people. Maybe we started this campaign about 6 or 7 years before, and in those now I remember how I was feeling in those days. Regarding this kind of campaign, do you do this campaign? Yeah, not just, but actually even at NASA, we do this kind of campaign. Therefore, anyway, wherever we go in the solar system, actually we should do it. And actually, this is not just somebody else's issue, but it's my own issues.
And this is from the control room. The Explorer will soon be ready for the next operation. That means it will go through the shade and they will go back to the normal operation. So after the launch, 1 year after the launch, the Explorer did the swing by of the Earth. And while it is during the cruise, and as a period, basically using the solar battery. And even during the evacuation at the impact, it's hidden the Ryugu, but it was in the area that can receive the solar rays. But after 4 years, the Explorer was in the shade.
What else do we have, guys? If you have just joined in and want to know more about this mission, thanks for subscribing,
regarding
Nick.
Hayabusa2.
Thanks for subscribing. Really appreciate that.
This is control.
Okay, something has happened.
Hayabusa2 has left the shade area. As soon it is going to start a new journey. Yes, that is a big year. Yeah, everyone was tense. Everyone was pleased with Fireball and excited, but at the same time, it seems that they were worried about the Explorer. We confirm that the Explorer is going well. And we received a lot of messages to the project members. It says I'm grateful for those, and I would like to cheer up, and I would like to express gratitude to the members. I respect the efforts of the project members, and thanks to a lot of information during your despite schedule, I think I felt that as if I were one of the members of the project. And Ion Engine, congratulations of the
guys. The happiness in the control center was because they received the signal from the Hayabusa2 spacecraft, and you must be wondering, like, yeah, they have done the maneuver and all, so yeah, they will be receiving the signal. So what's the big deal about it? Well, let me just tell you that Hayabusa 1 mission actually had this problem, like they collected the samples, that was not a problem, but the actual spacecraft re-entered the atmosphere, and they couldn't do anything about it, and that's why they're so happy that Hayabusa 2 spacecraft is healthy, and now it can proceed for its next mission to 2 asteroids and study them, and maybe touchdown also is planned, because it has right now has 1 target marker also left and 1 impactor, if I'm not wrong.
If we can collect good sample, that's really perfect. A report from Australia, where we are looking forward to report from Australia. So while we are waiting, I would like to show you the video of separation.
Okay, video of separation. That will be cool to watch. I mean the separation of the capsule, not the parachute or heat shield. Oh, okay. I can't play. Okay, so this is the new mission array. I mean, it would be best if they have played.
So we're now going to a new journey. The target is
Okay, so it won't be a good. So this is a 1998. I must tell you, this is a 1998 KY26 asteroid, which the Hayabusa 2 is now proceeding to. And this is there are two asteroids, as you can see, 2001 CC21 and 1998 KY26. On for 2001 CC1, it will be just a flyby, and they will take images and perform scientific equipments in a flyby. But for 1998 KY26, that asteroid is a unique one because that's a 30-meter asteroid only, and it's a very small asteroid, and they will try to rendezvous with it. And then after that they will also if possible they will be touching down on that asteroid. So the problem with that asteroid, the KY26, is this KY26 rotates at 10 rotational period is around 10 minutes only. That means it is rotating so fastly. And now you can see that it is just flyby past this 2001 CC21. It will be a challenge for them to have some images and run some scientific equipments during this flyby, because the camera is static. They have not that flyby optimized camera. But after that, this is, yeah, two Earth showing Earth flyby basically into 2027 and 2028. And then it will rendezvous with this asteroid. So this is a unique one because this is just a small asteroid. And hence they need more higher precision and guidance for this asteroid, because this is a really small one, and rendezvousing with this asteroid will be require so much accuracy. This asteroid rotates at around 10 minutes. The rotational period is 10 minutes. So wow, that means it is rotating really very fast, and we don't want I mean any problems with that. So yeah. So this asteroid, why have they visited they are trying to visit this asteroid, is because this is potentially hazardous asteroid for Earth, and they would like to study it for the planetary defense. That's what they quoted. And yeah, that's the thing. Wow, man. Okay.
Well, actually, that we could see the extended missions video. And about this one, let me introduce some messages of the support. I'm always sharing this project, and I love Hayabusa 2. When seeing you who are working alone in the far away in the space, actually, I'm so happy, and thanks to you, I could overcome the entrance exam, and under the very dark atmosphere of the pandemic, corona pandemic, thank you for a very very
Thanks
happy
for that
and
CHF20
happy
Q
and
covering.
hopeful
Thank you so much for that.
information.
I don't know
And at
what's
the
that
Sagamihara
currency, but yeah,
control room,
thank you so much for
actually
that
now we get
donation. Really
latest
appreciate that.
information
It
from Australia.
really helps the channel. Thank you so much
Okay,
for
at
this thing. Q covering. Thank you so
7:07,
much.
the capsule's landing point was detected, and actually, the local team will start the activity or work to collect the capsule.
ありがとうございます。
Thank you very much.
本当に順調に
Everything is really smooth and so surprising, and we are going to have the finale very soon.
さてここまで約1時間半にわたって
So far,
参りました
we had this program
カプセル
for
中
1
継
hour and
いかがでしたで
30
しょうか
minutes. How did you enjoy today's live distribution of the Hayabusa2's capsule collection? And I would like to have some word one by one. Well, I'm Okayama, and the landing point was detected, and actually we can expect a lot for the collection of the capsule, and I'm so happy. I was so happy because we could see this fireball together with you. And actually, maybe I made a mistake in the naming of the star. Till now I said that it should be near the canopus, and actually, this could be seen even from Japan. And this is a replay. Okay, now the fireball is chased, by the zoomed camera, right? Actually, it is horizontally flying Hayabusa2 the capsule. This is a
This
fireball
was so
of
good
the
to watch.
capsule.
This thing,
I'm so happy
I'm also so
to
happy.
see it
Wow.
anytime.
Finally, guys, they actually went to the asteroid, took the samples, and it re-entered the atmosphere and
I
landed.
really hope that,
Wow.
I really hope that it will be corrected very safely and surely.
I mean, I just
Well,
can't
actually,
imagine in which
I
era
cannot
am I
stop seeing
living.
it, and this is so beautiful, long tail.
These sites, these events are so delighted. When I watch these, I'm so delighted.
See it, and I was
I
so
mean,
happy.
I don't have any words.
And that, anyways, the helicopter will go to get it. Anyway, actual collection will be done tomorrow morning in Australia, and maybe tomorrow morning when you wake up, I'm sure you can hear the very good news. And let's look forward to it. That's all from me. Everybody, thank you very much for seeing this program until late. And actually, this is a very historic moment, and we could see it's real time. We could share this time. It was so fantastic, and Mr. Tsuda said that, the voyage of the Hayabusa2 will continue even from now. Therefore, we'd like to share with you again. Thank you very much for everything.
管制室の細田さん
And Mr. Hosoda in the control room, can you hear me?
相模原管制放送です。
Yes, I'm
お
Hosoda.
願いします
Could you say the last word? Okay, thank you very much. Until the late. And actually, watching this explorer, all of us, is a fantastic moment and so happy work. And the director, Mr. Inada, said that.
情報に対して非常に少年のような笑顔を浮かべている。
Actually, he showed a great smile, and because he had very hardships in the case of the first generation Hayabusa, and of course not just Hayabusa2, but the JAXA will continue to have lots of projects. Therefore, anyway, based on this success, anyway, would you like to evolve ourselves? Thank you very much, and actually, Mr. Hosoda.
いただきますと
I'd like
どこか
to
の誰かがい
introduce
つの日にか口にす
you,
るであろ
the
う
comment
あの時に
anywhere,
あれ
and
に影響されて
somebody,
今の職
you
に
know,
就きました
somebody would say that
まさ
I
に
was
あの時に見たあれ
influenced by
今
that,
私たちの手で作っ
that
ています
we saw that time, that's one I saw. That is the word of Mr. Hosoda. Actually, among the support messages, thanks to this project, some young people entered, the aerospace department in the university. Therefore, all the people who were involved in this project or Hayabusa2 project, everybody was so much impressed. And also, all the people, in Japan and in the world, thank you very much for that, especially in Japan and in Australia. Actually, this is in the middle of the night or even, the early morning. And this time, to be wake up, it's quite severe, however. Anyway, we'd like to announce the end of today's, the distribution. Thank you very much for everybody. Good night.
Okay. So, guys, man, that was hell of a ride. I mean, that was hell of a ride for Hayabusa 2 and for the space capsule. This is so cool to have. I mean, I just can't tell you in which era we are living right now, and this thing, these kind of events, like the December month of 2020, as in for the space flight, it's very cool. Means there are three major things which are happening in December month. First of all, this thing which happened successfully, and then we have the Starship flight, and then we also have a Chang'e 5 moon sample return. I mean, 2020 was the worst year. I can guarantee you that, but in December it is like trying to correct whatever it has done. So for December 2020, for the space flight and for the space community, this is such a good year, because this one, I mean, better than me that we have such a good thing for the space flight as well as for the uh, space events as well. Yes, Labrat. Okay, now the thing is, as you can see right now, the distance from the Earth is increasing. That's okay, because it is still in the mission is still progressing. I mean, this thing which you are seeing right now, the kilometers, that is the Hayabusa 2 spacecraft kilometers. That's the thing, yeah. But the capsule has already landed, and we are just waiting for them to find it properly, and yeah, that's the thing. I mean, I just don't have words for this thing, whatever this thing is happening. Seriously, can't have. If you just joined in and you missed whatever I did, I mean, the presentation which I did for this mission, you can always have a look at that. But in galleries, we can have one thing which is very cool to see, and that will be this thing. I mean, Japan is always there, and the animes don't leave Japan. I mean, any mission or anything, the animes will be there. As you can see here, the spacecraft, anime version of the spacecraft equipments and everything. This is so cool. I mean, wow. And these were the some of the payload cover color images and logo mark. Yeah, everything. This is the most good image which I find. I mean, this covers everything. That's the thing. Thank you, Louis Smith, for that. And this is the thing which you just missed. If you just missed during the starting of the stream, this is what it had. These are what the components of this mission, guys, which you are seeing right now. This and this, you can say, were the rovers of the mission. And Richard, thank you so much for €2 super chat. Thanks for your enthusiasm. Go Team Space. Yes, Richard, you are right. we are very 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 delighted to living in this to live in this era, and thank you so much for this. It really support the channel. So these are the rovers, which you can see it does not have any wheels, but it has wheels inside it, you can say, because it has reaction control system, which is the reaction control wheels, or you can say that uh, which rotates it. And this rovers basically not roll on the surface. Yeah, it rolls but hops on the surface, because the gravity of that asteroid was so weak that you can hop on the surface by internal reaction wheels. That's why it looks like this. And this was the lander, which was made by German and French space agency. This was the capsule, and this was only the thing which entered the atmosphere, and they are not, right now they are looking for it. This was the impactor, and it had, you can say, explosive material, because this thing actually, when got separated from the spacecraft, the Hayabusa 2 spacecraft, it launched one 2.5 kg copper projectile towards the asteroid at a speed of 2 kilometers per second. Yeah, and why did they do that? They did that to expose the inner surface of the asteroid. Okay, this is the deployable camera, which they also separated to catch that impact event, because they needed to protect their spacecraft. Okay, and hence the spacecraft performed one hazard avoidance maneuver, and hence it, you can say, went behind the asteroid, or the, you can say, the opposite side of the where the impact was created, to be safe from all the debris which could come out of the crater. So that's why. And to catch that event live, they actually had a deployable camera. I mean, this mission is so underrated. I mean, we talk about so many other missions, Mars mission, rover mission. I mean, they are also very complicated, but this had so many parts. And researching about this and knowing about this, I mean, I'm so happy I did some research about this and got to know about so many things for this spacecraft. This was such a complex mission. I mean, this is underrated, man. The hype which it didn't get, I mean, it should have got that hype which other missions get, the Mars rover, the Mars mission, and those kind of a thing. The technology which they are using, I mean, can't they, you see, they have so many parts, so many rovers. Although this one failed, this rover failed on before the deployment only, but everything else was successful. And these are some target markers which was deployed on the surface of the asteroid, so as to mark the point on the asteroid when and that marker actually helped the spacecraft during its descent towards the asteroid, because that marker is a reflective marker. These are some spheres which are reflective spheres, and hence the camera of the spacecraft was able to catch it and mark it, and hence were able to follow it towards the during the descent. And this Hayabusa 2 spacecraft has this ion engine thruster, which you can see. And you can see these three are lighted up, but not this fourth, because this fourth is a backup ion thruster. The main one are these three only, and these three are working perfectly. And these are the attitude control thruster, and obviously these are the solar panels on it. Wow, man. I mean, wow. Okay, so China, no, Sam, the China is not returning the samples from the far side of the moon, but from the near side of the moon. But yeah, that's a sample return mission. And if I get something, then that after the docking, say now, right now, the docking process is going on for the Chang'e 5 spacecraft. And if I get something for that, I mean, if I get any stream or anything which I can stream, I'll definitely be uh, streaming that. Just a sec. Okay, yeah. And now we are just waiting for that to happen. And the officials have said that in Woomera, helicopter has taken off at 3:17 JST to look for the capsule. Okay, that is really cool. Let me share that with you only. Yes, YouTube 1024. This mission is more complex that one, because it had so many things which was done first time for any nation. That was the thing. And this is, I believe, for me, this is a very underrated mission. I mean, this didn't get any hype which it actually deserved, because right now also the mission is continuing and it will be continuing till 2031. I mean, and does any spacecraft live for that much time? In 2014 it was launched, and until 2031 it is supposed to do its mission. Wow, I just don't have any words for it. Let me see if we have something else. I have something else to show you, and then we can go in. Okay. Meanwhile, NASA's also has approved its one moon orbiter mission. I would be needing some more updates on that, but yeah, that was one thing which I would like to show you and update you about. Anything else do we have? I don't think so. Oh yeah, one thing which I can definitely show you is the mission profile of this mission. How could I forget it? Whatever I just told you is there in the form of mission profile. So let me just pull up that for you. Okay, here we are. Where is it? Where is it? Yeah, here we go. Okay, this is cool, and now you can have a look at it, hopefully. Yeah, so here it goes. This is the mission profile with the actually whatever I explained you, this is in a video format. And this spacecraft itself looks very good. In the form factor is also very good looking, I must say that. So in 3rd December 2014 it was launched from the Earth surface from Japan only on board the H2A rocket, and in December 2015 it performed its first Earth flyby, and then at March 2016 the ion thruster was started to perform the TCM maneuver, the correction maneuver basically. And then this is the asteroid Ryugu, which it is trying to catch up. This is just a mission profile in a video format, which whatever has happened now. Mission is already successful. They have already done these many things. It arrived at this time, and then obviously it remained there for 1.5 years. The mission control center was driving that thing, Wayne. Nobody was inside it, obviously. So you can see these three, there are 3 ion thrusters, not 4. The 4th one is for the backup one. And then it arrived at the asteroid, rendezvoused successfully and captured it. So this is that. Okay, so for this mission also it was like Osiris Rex only, that they thought that this is a very sandy asteroid, but when they actually went there and got to know that yeah, this is not a sandy asteroid, and they actually need some very good something to have their collection properly. Same like Osiris Rex. But OSIRIS-REx had their equipments to perform proper touchdowns and sampling, but here they didn't had, but they somehow managed to do that with the target markers. This is the MASCOT rover or lander, whatever you say, which was deployed, and the role of it was to study the surface of the asteroid, obviously you can see here. And these hops of the rovers, which you can see here, can last about 15 minutes. The gravity of this asteroid is so low, and that you just don't need anything, you just can hop on the surface. This is their rover or lander, which was battery powered, and it operated for 17 hours and collected the data. Actually it sent the data back towards the spacecraft, and then these GNC sensors, guidance navigation sensor obviously, and then we have this mobility mechanism, the reaction control system. This was how it actually maneuvered on the surface. This is how it all the rovers maneuvered on the surface. Battery is there, supply for 16 hours, and it went for 17 hours actually. And then these are some radiometers, the scientific instruments which it had. Magnetometer, determine the magnetic field of the asteroid. This actually, Japan has this thing like they don't really release much of their info, and hence this thing which you are right now seeing was released by German Space Agency. And that's why it is like more focused on their rover, MASCOT rover, which you can see here. But they have this thing for their whole mission, so I think they will be yes, they have this mission profile video. Transferred its data, and then transferred the data back towards the Earth. The spacecraft transferred it. And then Japan then transferred the data back towards Germany for analyzing it. Now for the Hayabusa 2 mission, now they had this thing, their impactor, yeah, the small carry-on impactor which they took, which I would like to call it as anti-asteroid. It's not like anti-asteroid, but it's explosive kind of a thing which actually impacted the surface. It performed a hazardous avoidance maneuver, and then boom, it went back there, and then it performed a slow touchdown and collected the sample by again firing a bullet. That was a bullet, and it actually ejected some of the particles of the surface towards its sampling head, and the samples were collected. This is how they were collecting the sample. This is totally different from OSIRIS-REx, which had the pressurization of the air to collect the samples. In there they aimed to collect only some few grams of the sample, and that's why they were able to do that. And the end of 2020, yes, it arrived towards the Earth, obviously, and then the separation of the capsule happened. And now finally it is going towards the Australia, entering the atmosphere, aiming for Australia, I don't know the location, but southern Australia, yeah. That there is one desert, and yeah. Lab rat, yeah, it's very quick, very fast paced and very quick, and launched in 2014 and arriving in 2020, and mission extension till 2031. Wow. See, this is the JAXA's website, and they haven't released much of their images and everything, which we know. And I mean, their mission object, that's some agencies do. They don't like to do the much of the, I mean, I don't know. But yeah, let's have a look at some camera images which it captured from the surface. Not looking that much good. Okay. This is when they actually it got near the asteroid, and you can see the actual composition of it. Wow. Okay. This was the actually movie which oh wow, is this bullet striking the target? I mean, I didn't see this one. Oh wow, we had this one also. Let me just play it once. Wow, look at that. Just look at that. I mean, I don't know whether it is a real image, real spacecraft taking this image, or was it like I captured on the Earth and then it. I mean, this is also very cool to see. I think it was, yeah. It was simulated on the Earth to collect the sample or to see how it behaves. You can see the regolith which actually came off the surface. It quickly settled down. Okay, cool. What do we have in here? Rehearsal 3 operation and animation. Okay. Yes, this we wanted to, I actually wanted you to see the before and the after comparison of the impacting site, which you can see here. The before this and the after the impact, you can see after the impact the surface turned black. That black surface actually was not because of the impactor hitting the, I mean, that was not because of there was some explosion or something like that. It was because of the impactor hitting the surface, but it is not like something burned there and that's why it turned black. It actually turned black because it exposed the inner surface, inner layer of the asteroid, and the inner layer is like that only, blackish in color, because mostly the layers which are beneath the surface are dark in color for many of the celestial bodies. For moon also, from the scooping operation which we got to see for the Chang'e 5 mission, we saw that the actually the inner surface is kind of dark, and it is self-explanatory also, because if you know, if you can see, if you or if you have made this experiment in your, if you have done this experiment in your home, if you take one chart paper or a colored chart paper and uh, keep it of outside your house for some days, that will just bleach out. The color will just bleach out because of the radiations coming from the sun. We have the magnetic field of the earth as well as the ozone layer to protect us, protect those radiations, but still some radiations come and it changes the color. So that's in space we don't have any protection from the radiation and anything, so all the radiation from the sun, from the galaxies, galactic cosmic rays are also there, which hits the surface. All those radiation hit the surface and changes the composition. Obviously, that's why we have that thing. Okay, so do we have anything else to see? Yeah, this one. This was, you can say, a video which actually was taken from one of the rovers, and it and it, you can see it actually got the shot of the sun transiting in the other direction. Wow. Not the sun, actually the asteroid was moving, obviously not the sun, but the asteroid was moving. It was rotating, and that's why you can see the sun was going in other direction, and the rover actually captured that thing. And this was the best shot, I can say, of the whole mission which we got. For me, this was the best one. And these are some touchdown videos. This is how we got the touchdown. I mean, okay, yeah, come on, going in, and here we have the touchdown. And just after the touchdown, as you can see, all of the regolith, the flakes, the stone, the soil just went haywire and all over the place. Similar shot we saw from the Osiris Rex also. And yeah, why does it go all like this? Because of the gravity. There is very less gravity there, and everything just go and spreads out in all direction. So the first touchdown, and we have the second touchdown. The second touchdown is at that site where the impactor had impacted the surface. So this exposed some other materials inside the asteroid, and similar consequence was there also. And here also we can see that it actually broke some parts of the surface, the rocks or the big boulders which had been there. It actually got there and crushed those boulders. Same happened with Osiris Rex mission also in asteroid Bennu. And whenever that happened, that means you are actually doing some great part, and that means you will be getting some good amount of samples. And we also had one image of the creator, the impactor creating the crater. Let me have that for you. Here we have, and we can see from here that how this thing okay, changes. Wow, just see this thing, man. This is the where this is the images captured by the deployable camera, and we can see the impact on the surface of the asteroid, and the deployable camera actually captured that. Obviously the deployable camera didn't had a good resolution, but good enough resolution to capture this thing, this imagery which you are seeing right now. And analyzing this imagery, we can also see this thing, like this asteroid is moving towards us. That's why the crater was becoming more of you can say darker in color and more evident, I should say. Yeah, evident is the word. Because the asteroid was orbiting, not rotating, sorry, the asteroid was rotating and it was moving towards the camera, and that's why it happened. Also we can see that the plume actually was there for some time, and that means this thing has a very less gravity because it didn't settled down. Also the plume signifies two events, two things basically, not events, two things. One is the weak gravity, second that the um, this the samples of the asteroid is not sticky. Okay, that means those rock particles or the soil particles are not pulling each other and are not very sticky. They are just spreading out in all direction. They are not holding them together, and that is also very good to have for a sample return mission. And yeah, that was, I think, it. And I think I can now end this stream. What if the sample contained diamonds? I mean, this is a carbonaceous asteroid which they visited, and diamonds are made up of carbon. So you can expect, yes, they can find diamond. No, 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 they won't be finding a diamond, because diamond require high pressure uh, carbon to be pressurized so much that they form a high pressure material with the high temperature also, which is not a good environment there on asteroid. That's why. So but yeah, whatever they are finding, they will be now analyzing it. Firstly, they will be searching for the capsule, and then they will be analyzing the samples, and finally okay, so for the analyzing also they had these steps. Firstly, after collecting the samples from the landing location, they will perform some preliminary test in Australia itself, and then it will be flown back to Japan, and then Japan will perform the samples test there around for 1 to 2 months, and after that it will be shared with the international community. I mean, the Japan has been with the collaboration with many agencies around the world. NASA, Australian Space Agency, obviously, NASA is there, the French is there, the German is there. So they will be, the samples will be shared with all of them. And since the Japan is sharing the sample of the this asteroid Ryugu to NASA, NASA will also be sharing the sample of asteroid Bennu to Japan. So you can see how is it going, and this is a perfect example of space collaboration, and how it can actually change the way we look at space exploration and help in getting all these things done successfully. Wow, man, this was such a good mission, and I'm so happy I witnessed it and I researched about this, and actually we actually talked about this, and yeah. So in conclusion, I would like to say that I firstly was so nervous for this stream because, uh, believe me or not, I actually had to research a lot, as well as had to manage a lot, for because we had so many parts to share. I had so many parts to share for this mission: the Hayabusa spacecraft, the payloads, which were so many. Then we had the rover images, the sampling process was there, the recovery was there, and then finally the launch, not the launch stream, but the event stream was there. Everything was to be managed, and I was so nervous, but yeah, it happened. Okay, and I would like to thank my moderators also, Louis Smith and Labrat, for their contribution in managing the chat. Thank you so much, Louis Smith as well as Labrat. And yeah, now if I get some chances, I will be sharing the stream of the Chang'e 5 docking. It is right now, docking process is going on. It's just that it will take 4 hours for it to dock. So yeah, we can expect something from it also. And finally, we also saw that fireball, and fireball was such a good delight for our eyes to watch. I mean, re-entering the atmosphere, and that fiery re-entry we could see from the earth, and that was such a heck of a good thing which we saw. So yeah, thank you so much everyone for tuning in, and hopefully see you again tomorrow. First of all, tomorrow we have a good mission coming up of the Falcon 9, which will be launched to the International Space Station for their first ever flight of their upgraded cargo Dragon, which is can take 50% more science to International Space Station, as well as that will be the 100th successful flight of the Falcon 9, which will happen tomorrow, as well as that mission. Okay, so I won't disclose every milestone right now here on this stream only. Do join me on that stream tomorrow. I'll be streaming that. So yeah, thank you so much for tuning in. It was really delight uh, streaming this and interacting with you guys. Thank you so much. Until then, this is Priyanshu Roila signing off. You just saw Rocket Gyan. Stay safe, stay healthy, and